To find the sum of n constant terms, well, let's do an example here. So like if we took the sum from 1 to, somebody give me a number for n.
30, 40.
30. And then give me a constant.
6, 4.
Okay. So if we were adding up 6 plus 6 plus 6 plus 6, like adding 6 30 times, that ends up being the same as
180.
which is the same. I think you meant to say 30 times 6, which is 180.
Wait, what is
That is true.
What is that? Shouldn't it be I is equal to 6 because you're starting at 6? Like that's your first number.
No, but it's not saying. So it's saying that the rule is 6. So you're adding up 6 plus 6 plus 6 plus 6 30 times.
So I can be whatever.
For what we're doing this, I will be 1.
Wait, I will be one.
It doesn't technically, in terms of series, I does not have to be 1 for what we're doing and the formulas that I'm giving you, and for what we're doing with these sums, I will be 1. Okay. So let's say that we are trying to find the sum of the cubes of the first 6 positive integers. So here's another formula that I will give to you. I do not have any fun story for it. In sigma notation, that would be from 1 to 6 I cubed. So that would be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed plus 6 cubed, right? And that formula would be 6 squared times 6 plus 1 squared divided by 4. So what is that? 36 times 49 divided by 4. 36 divided by 4 would be 9. Times 49 is 9 times 49. Speaking of what? 400. Here we go. We're not talking about the 49ers. But you guys, I did win my fantasy football league. I beat my husband in the championship. I did.
What's the punishment for the loser in the league?
We don't have one in that one, unfortunately. It would be my mother-in-law. I'm pretty sure she came in last place. Who had basically all 49er players on her team. Like she drafted McCaffrey first and then had like Debo and like all of them did not.
Good luck, guys.
What? Do we live in a barn? No one closes the door.
It's closed.
Because it's so hot.
Not fully.
It's warm outside.
So true.
Now, in the same way that limits, derivatives, integrals have had certain properties, like the constant multiple rule, these sums also have that rule. And think about it. If we have our rule, a sub I is equal to 3i, that means you'd have 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4, right? And so on. Couldn't you technically think about factoring a 3 out and then multiplying that by the sum of 1 plus 2 plus 3 plus 4 and so on? So we are allowed to think about pulling the constant out in our summation notation, like if we are trying to evaluate the sum from 1 to 12 of 3i, we can think about pulling that 3 out. And then now we are set up to use our summation formula, which I will give you, right? So 12 times 12 minus 1 divided by 2. What is that? 3 times 6 times 11 will be 234.
We don't need to memorize any summation formula.
Nope.
Feels like a trap.
Is it plus 1?
What?
12 times 12 plus 1.
Is it? Dang it, it is. So that should actually be, I just wrote down the answer. I'm just making sure you're paying attention, you guys.
Thanks.
Times 13.
Oh.
That ends up being 234. That answer is correct. Just remember Gauss. And then just like with limits and derivatives and integrals, we have the summation property, right, where if we have a rule that is a sum or difference, we can think about splitting up the sum. So for example, if we are wanting to evaluate the sum from 1 to 20 of I squared plus 3, that's going to be equal to the sum from 1 to 20 of I squared, which we know a formula for, plus the sum from 1 to 20 of 3. And then we are set. We can use our formulas. So referencing the I squared formula. So 20 times 20 minus 1, no, plus 1, times 2 times 20 plus 1, all over 6. And then plus 3 times 20. So this formula goes there, or matches up there, and this is 3 times 20. So then thinking about simplifying that, what is that? 2,930. You can check me. Now going in the reverse, you do not need to evaluate the sum, but I want you, or I guess you're not so much going in the reverse. I want you to come up with the sigma notation that represents each of these sums. See if you can do it. So work with like 1 or 2 people that you're sitting near. See if you can come up with the sigma notation where I is equal to 1. The second one in particular, it's a little bit trickier to get it with I equal to 1 as your lower bound of summation, but it can be done. So why don't you guys take a couple minutes and see if you can come up with the summation notation for each of those. Okay, and you can talk to 1 or 2 people that you're sitting near.
What's the like end?
It's I times 1 I over 3. It's I over 3 is the rule.
No, the
And it
because
starts
or the
with
250.
I
it
was
starts with 3.
negative 3.
It starts with I equals 3.
I was negative 3.
That's at the end, right?
You want to try and figure out what the rule would be for each term. Like it doesn't necessarily have to just be I.
The rule is, yeah, but we can make, the rule would be different, right? So the rule is like 5.
So that's right.
Yeah.
Then it would
So
be
I think it's
50.
250.
That's not what I did, but does it work?
If it's,
Wait, not 50. 50 times
I start
That
at
works.
0, I think, right?
Because you said you did 3
0
times 1 would be 3. You'd have 0 in your denominator for the first term.
That's because if the end would be,
This looked like to you.
maybe it's, I don't know.
3 minus 3 would be 0.
Wait, why do you even get 50 though?
Because the end would be, because the rule, the end would make it.
Wait, but where did you get
This
this?
one was
50,
You get it?
250 divided by 5. Because the rule is 5. Because it starts at.
Oh, it's just.
And then since the other one's 8 divided by
Oh,
4.
Yeah.
Oh, I see.
Maybe, but like, I don't know.
I-
I'll write either.
Right?
Yeah.
What
this
Okay, I think you're right. It's I.
What is I? What does that change?
That's the power of.
You're writing the rule for each term in terms of I. So whatever I is, it indicates what you're starting with, right? And then you go up to whatever N is.
Is your divided for each term?
What's 729?
So,
Drew, what you doing over there?
No, I think it's 3 to
Not
the
right,
power
because
negative
it's
I.
What are you guys
Which
watching?
one?
It's 3 to the power
It's not.
negative I.
Oh,
I
Oh,
over
and you
3.
raise, and that would be.
Yeah,
Definitely.
that divided by.
Or that divided 3.
Yes, negative 2.
Depending on which one.
Either
You
you're
divide both.
Yes. I know 100%. What is 3 to
729
the
divided by 3.
27
Oh, wait,
times
you're
3?
right. Wait, we can't have I be like 0 or something?
You can start at 0 if you want,
That's not so big.
Wait,
What number?
are we supposed to make, are we making it smaller?
but you
3
can
to the 6.
have I be equal to 1 for all of them. It can be done.
Oh, wait, no, it's 1 over.
We got it.
So then it's making it. So big.
You sure?
Okay.
Okay, can I check?
You are not evaluating
But you
the
multiply
sum.
by
Yeah, that's
729 times 3.
Yeah, that works.
2, 1,
And then put brackets around
or
this,
The rules?
around the rule, and then I would put, so it doesn't look like a mixed number, put like parentheses or put a dot for multiplication.
I don't get it. Like, can I just do this instead? Like this?
3.
And then parentheses around it?
Sure.
This works?
3i over 10.
You
So that, wait, now that's what I said.
Write it all in parentheses, so it's not like
Wait, no.
the sum plus 7.
maybe.
That's what it looks like.
Wait, yeah, because I one.
Yeah.
Oh, is it yes?
And then the end, the
Can we
last
split it?
one
No, it's just this.
is
No, these are just notes.
3. Is it 10 over 10?
Guess
Or
what?
are we dividing this by this?
I think this works.
No.
No, this one.
I mean, oh, because the I
So
don't
it's
know.
I's 1.
Yeah.
Right?
It's
Well, I's always one though.
I mean, because it starts at
It's
1.
in the-
Oh, this one starts at 1 too.
Yeah.
Wait, I don't know about this one. Oh, it starts at 1?
Anyways, now I can do this, bro.
Why does it start at 1 and
Now I
then
can do
1
this.
third? Oh, so it's like
wait.
1.
For the, do you need it in a minute?
No, it's okay. You can say it.
What are we thinking if we were starting I at 1? What are we thinking is the rule? For each-
250 and then 5I.
Oh, the rule would be 5i, right? Because that could be written as 5 times 1 plus 5 times 2 plus 5 times 3 plus 5 times 4, all the way up to 5 times 50. Okay. So that's the first one. This one's a little bit tricky. Did anybody get it where I is equal to 1? Leo?
I equals 1 goes to 7. 3 to the power of negative I plus
3, say it one more
1. 3
time.
to the power of negative I plus 1.
Negative I. Like plus 1. Yeah, that works. You also, the way that I had the rule written whenever I did it that way, was 1 over, just so that it looked like each term, 3 to the I minus 1.
Oh, that's basically.
Now, if you did it with I equal to 0, then you could just go up to 6 and you could do 1 over 3i. That also works. Or 3 to the negative I. And then this one's pretty straightforward. Okay. What is n? We're going from 1 to 10. And then the rule is 3 times I over 10 plus 7. Make sure you have parentheses or brackets around the rule, because otherwise it looks like the sum from 1 to 10 of 3 times I over 10, and then like you're adding plus 7 to that sum. So similar to how we have to have grouping symbols with the integrand. You guys have a short assignment due next class. And you even have the answers. Oh, it's from the textbook, so you could look in. Does anybody recognize that handwriting?
Mr. Green.
It's Mr. Green. Thanks, Mr. Green.
Cursive.
Oh wait, yeah, it was cursive.
Um,
Great, I don't remember that.
So if you want to check your answers there might be some for us to talk about that are a little bit tricky, but it's a pretty short assignment.
Oh, I